CCTV, closed-circuit television, is a video surveillance system that transmits signals from a camera to a specific and limited set of monitors for security surveillance and monitoring. Unlike broadcast television, the signal is not openly transmitted to the public, but remains within a closed network designed for observation and recording. In this video, we are going to look at how CCTV works, explore the different components used in a CCTV system, and understand how information, such as a moving bottle of soft drink, is captured by a camera and displayed on a screen. We will also see how the camera converts real-world images into digital data made up of zeros and ones for processing, storage, and display. CCTV systems exist in different categories. There are IP systems that use digital signals and are often connected via Ethernet cables. These systems offer higher resolution, better scalability, and easier integration with computer networks and remote viewing applications. There are analog systems, which use coaxial cables and are typically more cost-effective for smaller or simpler installations. Wireless CCTV cameras transmit footage over Wi-Fi, reducing the need for long cable runs and making installation easier in certain environments. There are also standalone cameras with built-in SD card storage that do not require a central recorder, as they can store footage internally. Here, we will focus mainly on analog systems to clearly understand the fundamentals. To have a complete CCTV system, we must have a camera, a power supply, a recording device, and a monitor. For analog cameras, the recording device is called a digital video recorder DVR. For IP cameras, the recording device is called a network video recorder NVR. In this discussion, we will focus on the DVR. Inside the DVR, there is a storage device called a hard disk drive, which stores recorded footage for playback and review. Monitors are screens used for viewing real-time or recorded footage. They allow users to observe live activities or replay previously recorded events. There are different connectors used in CCTV systems. One of the most common in analog systems is the BNC connector, which stands for bayonet Neil-Concelman. It is a standard twist-lock connector used to securely connect analog and HD surveillance cameras to DVRs via coaxial cables such as RG59 or RG6. The BNC connector ensures stable, high-quality video transmission with minimal signal loss in analog systems. Many modern BNC-based systems support high-definition formats up to 4K resolution. BNC connectors transmit raw analog video signals from the camera to the DVR. They feature a bayonet mount mechanism that locks with a simple twist, preventing accidental disconnection. Common BNC connector types include the male BNC connector, BNC female-to-female adapter, and BNC to RCA converter for compatibility with other devices. In addition to video connectors, we also have power connectors. These are used to supply DC voltage from the power supply unit to the camera. Let us consider a practical example. We focus the camera on a jumping bottle of soft drink. The camera captures that movement as light information. This information is converted into an electrical signal and sent to the DVR through a coaxial cable connected with BNC connectors. The DVR receives the signal, processes it, converts it into a digital format if necessary, compresses it, stores it on the hard disk, and sends the output signal to the monitor. The monitor then displays the video, so we can see the moving object. To understand this process more clearly, we first need to see how a camera works. CCTV cameras capture, record, and transmit video by converting light into electrical signals using an image sensor. The image sensor can be either CCD or CMOS. The camera captures a continuous stream of images, known as frames. These frames are transmitted via coaxial cable, Ethernet cable, or Wi-Fi to a recording device such as a DVR or NVR for display and storage. A typical CCTV camera system consists of several essential components. The outer body often has an IP66 rated metal housing, which is durable and weatherproof, protecting the internal electronics from dust and rain. At the front, there is a glass cover protecting the lens and infrared LEDs. Many cameras have up to 36 infrared LEDs, providing night vision capability up to 100 feet. Inside, there is an IR cut filter, a lens often around 3.6 to 4.6 millimeters in focal length, a high-resolution image processing IC such as 960H for analog systems, and connectors for power and video output. The infrared LEDs emit infrared light during low light or night conditions. This light reflects off objects and returns to the camera lens. Light from any object, whether visible or infrared, consists of photons. These photons pass through the lens and are focused onto the camera sensor. The camera sensor converts incoming photons into electrical signals. The camera processor then converts these electrical signals into digital data made up of ones and zeros. For example, a CMOS image sensor is made of an array of millions of pixels. Each pixel contains photodetectors arranged in a pattern. Typically, each 2 by 2 pixel group contains one red filter, one blue filter, and 2 green filters. Since there are only 3 primary color filters, but 4 photodetectors in the 2 by 2 arrangement, one color must repeat. Green is repeated because the human eye is most sensitive to green light. This arrangement is called the Bayer filter pattern. In this pattern, blue and green appear on odd rows, while green and red appear on even rows. Each photodetector is built on a silicon substrate and contains a photodiode to collect photons. It also includes 3 transistors, a row selector transistor, an amplifier transistor, and a reset transistor. Above the photodiode, there is a color filter and a microlens. The microlens focuses incoming light onto the photodiode, improving efficiency and sensitivity. Each photodetector consists of a silicon substrate, a potential well, and a photodiode that measures incoming photons. The color filter ensures that only specific wavelengths of light reach the photodiode. The transistors and internal buses amplify and transmit the electrical signal generated. This array of photodetectors forms the image sensor chip located at the focal plane of the lens assembly. Around the pixel array, there are analog and digital circuits used to process signals and assemble the final digital image. For example, a 16-megapixel camera contains 16 million individual pixels, each extremely small, but working together to create a detailed image. To understand how a single pixel works, we look at its 3 main layers: the microlens, the color filter, and the photodiode. When light from an object releases photons, the microlens focuses them into a narrow path. The color filter then allows only photons of a specific color to pass through while absorbing the others. For example, A green pixel allows only green photons to reach the photodiode. The photodiode converts these photons into electrical charge and stores the change in electrons. The more photons that hit the photodiode, the greater the electrical charge produced. Each pixel also includes an amplifier to increase the signal strength. This amplification process is related to ISO settings in cameras. Higher ISO increases signal amplification, making the image brighter, but potentially adding noise. The camera processor reads the charge level from each pixel and interprets it as digital data. By combining millions of pixel values, the processor reconstructs a complete image frame. These frames are continuously generated to form video. In an analog CCTV system, the video signal travels through a coaxial cable along with a ground connection via a BNC connector to the DVR. From the DVR, the video output is sent to the monitor using an HDMI cable connected to the monitor's HDMI port. HDMI is commonly used for high-definition output ranging from 1080p to 4K resolution. Power is supplied to the system using a single-phase AC power supply consisting of live, neutral, and earth wires. The AC power is converted into DC power by the camera power supply unit and delivered to the camera through power connectors. The DVR is supplied with single-phase AC power. The monitor is also supplied with single-phase AC power. All these components work together as one complete system. The camera captures light and converts it into electrical signals. The DVR processes, compresses, and stores the data. The monitor displays the visual output. Through this coordinated process, CCTV systems provide continuous surveillance, recording, and monitoring for security and safety purposes.